Hey, I hope all my algebra people are having a great day today. Today with just a little bit of a talk on what we call point slope form for linear equations. Now, just before we jump into that, just a quick review of kind of our equations of lines. We had two forms for our equations of lines so far. We had slope-intercept, which we probably remember as y equals mx plus b, but all these parts have a different meaning, a different purpose. So just to review, m, remember, is the slope, and slope, of course, is rise over run, and just as a refresher to calculate that from 2 points on a line, we can say y2 minus y1 over x2 minus x1. Okay, perfect. Second part of that we need to mention here is this b. This b is the y-intercept, which, remember, is where our graph crosses the y-axis. So it's going to be some point of 0, comma, b, whatever b is. So there's a point on our line. Okay, so there was slope-intercept form. The other form that we've talked about is called standard form. And standard form was ax plus by plus, equals c. And we had some stipulations on those. We said that a and b and c actually had to be integers, which means that they can't be decimals or fractions. They have to be whole numbers or their opposites. So 0, 1, 2, 3, 4, and so on, or -1, -2, -3, -4, and so on. So the opposites of those whole numbers. The other stipulation on this was that a had to be positive. So those were our two stipulations on standard form. Okay, so our third form today, well, comes into play when I've got something like this. So maybe we've got a line that looks something like this, and we need an equation of this line. Make sure we always label our coordinates, our axes. Okay, so if I look at this one and I want to write an equation of this line, I can say, well, y equals, get that out of the way, y equals mx plus b using that slope-intercept form. And I can say, well, I can use this point because that's a point on my line, and I can use this point because that's definitely a point on my line. So it looks like I've got -3, 0 for an x-intercept and 0, 4 for a y-intercept. I can find my slope using my formula, or I could count my slope. It's moving up and to the right, so I know it's going to be positive just as a quick self-check. I'm going to go ahead and I'm going to use my equation. So I'm going to use my formula. So I'm going to go 4 minus 0 over 0, because those two are from the same point. They have to go over top of each other, minus -3. So I have a slope of 4/3. Okay, so I go back to my slope-intercept form, y equals 4/3 x plus, oh, and I know what the y-intercept is. The y-intercept's right here, so b is 4. There's my equation for my line. That works really nice when we have a nice y-intercept. But what may not work out so nice is if we have a line that doesn't have such a nice y-intercept. So let's go. So maybe I've got a line that looks more like this. Now, when I look at this, I can't tell what that y-intercept is. I can't tell if it's 3.5, 3 3/4, 4, 3 7/8. I don't really know what that is. My 4's in the wrong spot here, though. So 1, 2, 3. There's my 4. But it's somewhere between 3 and 4. Other than that, I'm not really sure. But what I can do is I can find two other points. Looks like I've got 6, 0. And I've got this other point over here, -3, 5. So using those 2 points, I want to try to come up with an equation for my line. And one of the nice ways to do that is to use what's called point-slope form. So we need to know what point-slope form is. Well, here we go. Point-slope is the form y equals m times x minus x1 plus y1. Okay, what does all that mean? Well, m is still our slope. x1 and y1 are the coordinates of any point on the line. Any point. I pick any point on the line, I can plug the coordinates for that in for x1 and y1. So let's see how that actually works in this case. First thing we need to do is we need to find the slope. So y2 minus y1 over x2 minus x1 looks like 0 minus, slide up a little bit, 5. I'm sorry, that's not 6, 0, that's 6, 1. What was I thinking? I need to fix that. 6, 1. That looks better because we're one above the y-axis, or the x-axis. So let's fix this down here. 1 minus 5 over our x value, 6 minus negative 3. Negative 4 over 9. Let's check that out. Let's make sure that that seems to look right with our graph. It's negative because we're moving down and to the right. Let's count them out here. Let's see. From here we go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9 over. So down 4 over 9. Perfect. Checks out with our slope. How do we put that to use? Well, I say y equals negative 9. Man, having an off day today, writing these down. Negative 4/9, parentheses, x minus, outside the parentheses, plus. Now remember, we had x1, y1. They just come from a point in our equation. So I can pick any point in our equation. I'm going to just select one of the 2 that we had marked, and that one's still on my screen visible. So I'm going to use that one, 6, 1. So I go down here, and I say, well, x1 is 6. y1 is 1. And I've now got an equation for my line. If I want to simplify that, I can, and I think I will. So I'm going to go ahead and I'm going to distribute my negative 4/9. Negative 4/9 x. Negative times a negative is going to be positive, so plus 4/9 times, I'm just going to write it as 6 over 1 for right now, plus 1. Okay. Y equals negative 4/9 x plus, I believe that 3 goes into both 6 and to 9, so that would leave me with 2 and a 3 there. So 4 times 2 is 8 over 3 plus 1 would be 3 over 3. Negative 4/9 x plus 11/3. Or if you like, I would take what's here, but if you'd like to change this into a mixed number, y equals negative 4/9 x plus 3 2/3. And we've got an equation of our line using point-slope form.